Welcome to the pre-calculus video for the notes for Unit 2B, Lesson 1, which is on rational multiplication and division. So we start by defining what a rational expression is. We say that a rational expression is a division between two polynomial expressions. You will see here there's a visual that says f of x equals p of x divided by q of x. P of x the numerator, q of x the denominator. Both must be polynomial functions, and we have this added constraint that q of x cannot equal 0, meaning our denominator must not equal 0 because we know that dividing by 0 creates problems in mathematics. So we are going to begin by working on multiplying our rational expressions. So you see we have the problem here, y squared minus 9 divided by y squared minus 3y. And we're multiplying that by the other rational expression, which is y divided by y squared plus 9y plus 18. In step 1, we are asked to factor out the numerator and the denominator. So we're going to look at our individual terms. I'm going to say my numerator for the first fraction, the first rational expression, is y squared minus 9. I know that that is a special form that factors into y minus 3 times y plus 3. I know that if I look at my denominator, y squared minus 3y, I see that this is two terms, both containing y. So I'm going to factor a y out of my denominator, which leaves me with y minus 3. For my second, my numerator is just y. My denominator of y squared plus 9y plus 18 factors into y plus 3 times y plus 6. So now I can get into my next step, which is rewriting this as a single rational expression. So all I'm basically going to do is write one long fraction bar. I'm going to write everything in both numerators. So y minus 3, y plus 3, and y. And in the denominator, I will write all of my denominator, y, let me put that in parentheses, y minus 3, y plus 3, and y plus 6. So all I did was write down everything that was in the numerator stays in the numerator. Everything that's in the denominator stays in the denominator. My step 3, I'm going to simplify the expression by crossing out and multiplying. Just to be very clear, when I say that I am crossing out, I must cancel the same thing from the numerator as the denominator. So I will see in my numerator that I have a y minus 3. I will cancel that out with a y minus 3 from the denominator. I see in my numerator a y plus 3. I will cancel that with a y plus 3 in the denominator. I see that I have a y in the numerator, which is just an individual y. So I will cancel it with an individual y in the denominator. Words of warning. First, when I have canceled everything from either the numerator or the denominator, in this case it's the numerator, when I have canceled everything from the numerator, I am left with 1 in the numerator. I must remember that it is still in the numerator. Second, you may have been tempted to cancel this individual y with this y that is in the expression y plus 6. Understand that we can only cancel factors. We can only cancel things which are being multiplied. This y is being added to 6. That's not multiplication, meaning I could not cancel out this y individually. It's either the entire expression y plus 6 or nothing. So for step 3, I'm going to, now that I've canceled, rewrite my expression. So in my numerator, I am left only with 1. in my denominator, I am left only with y plus 6. Now, if this had been a slightly more complex rational expression, I might have had to multiply more than just one term. Like here, I only had y plus 6, but if there had been an additional like y plus 2, I would be expected to multiply my denominator out in order to simplify. Before we can finish the problem, we must complete step 4, which is to identify the constraints. Now, as we said, a rational function can only work when the denominator is not equal to 0. So we're going to ask ourselves which values would cause the original denominator to equal 0. So I'm going to write y plus 6 is equal to 0. And solving this gives me y equals negative 6. So that means when I write my final solution, I'm going to say that this is 1 over y plus 6, comma, y is not equal to negative 6. Because if I say that y is not equal to negative 6, it removes the issue that comes with this being 1 divided by 0. Next, we want to move on to dividing rational expressions. What you need to remember is that dividing by something is the same as multiplying by its reciprocal. So this says write as multiplication of the reciprocal. So I'm going to write my first expression, 9x squared, divided by x squared plus 12x plus 36. And instead of showing this as division, I'm going to write it as multiplication, but I need the reciprocal. So my denominator is going to move up into my numerator, x squared plus 6x. My former numerator is going to now be in the denominator, 12x. So once I've rewritten this as multiplication, I already know how to do the multiplication. So I should be able to do this with very little difficulty. So we're going to follow the steps for multiplying. So first, I'm going to factor my numerators and my denominators. So I have 9x squared divided by, here we have x squared plus 12x plus 36. That is x plus 6 times x plus 6 times x squared plus 6x. We're going to factor out 1x, and we have x plus 6. And in our denominator, we have 12x. Now we are going to do step 2, where we rewrite the problem as a single fraction, large fraction bar. 9x squared times x plus 6. In the denominator, we have x plus 6, and 12x. To get into step 3, we're going to start canceling. I'm going to cancel this x with this x. I'm going to cancel this x plus 6 with this x plus 6. And now I'm going to do a little bit of simplification, because I notice I've still got this 12 and this 9x squared. Now, there's no x down here, so this x squared I'm going to leave alone. But 9 and 12 share a common factor of 3. So if I cancel out a 3 from each, that leaves me with a 3 in the numerator and a 4 in the denominator. So rewriting, what I end up with is 3 and my x squared in the numerator. In the denominator, I have 4 times x plus 6, which I'm going to distribute the 4, giving me 3x squared divided by 4x plus 24. Now I must complete step 4, which is to set the denominator equal to 0 to find my constraint. If 4x plus 24 equals 0, that gives me x equals negative 6. Meaning my final answer is 3x squared over 4x plus 24 with x not equal to negative 6. If you have any remaining questions, make sure you jot them down so that way you can ask them again the next time I see you in class.